Hi, today I will be talking about my third Capstone project, which is to explore the possibility of generating classical music using large language model. To do that, I'm going to download a dataset from Kaggle called MusicNet dataset. In this dataset, it contains MIDI files of some classical composer like Bach, Beethoven, Mozart, and so on. So I'm going to use the MIDI dataset to teach the model what a classical music looks like, and then tell it to continue generating from the example that I give it to them. Okay, so the idea is that I'm going to extract the MIDI into text, and then I'll feed it the last 20 time steps of the music, and then expect the model to generate 10 time steps after this. Then I'm going to shift by 10 time step. So now the model will see 10 of the previous example, and then 10 of the new time step that it has just generated. Then it will generate another 10 time steps, and so on. So that's the idea that I'm going to do in this project. Okay, so now I'm going to need to pick the model, and I have tried the 7 billions parameter version, and it seems to be too big for my hardware, and the training is too slow. So I have to stick with a smaller model. So that's the reason why I'm going to with a Gemma 2 billions parameter version. And this is a model that has just been released by Google in February this year. And it has been trained with a long context window of 8,000 tokens, which is enough for me because from what I have tested, I need about 6,500 context window tokens for the context windows. Okay, the way I'm going to fine tune the large language model is to give the input in the alpaca prompt format. So it's going to contain instruction and then some context like who is the composer, what's the key, what's the beat per minute, and so on. And then I'm going to give it some inputs to start with, so around 20 time steps. And then the model is going to generate the response from this. Okay, actually this is a training notebook. Okay, so yeah, this is a decoder only model. So it only contains the self-attention layer and the feed-forward layers. And this 2 billion versions contain 18 repetitions of the self-attention and feed-forward. So it has around 3 billion parameters. But I'm not going to train all the 3 billion parameters. I'm going to use a technique called low rank adaptation, or LoRA, to train only a subset of the parameter and then add to the original model. So the weights of the original model is going to be frozen, and we are going to train a new low rank matrices and then add that matrices to the model. So with a rank of 64, I'm going to train only 78 million parameters, which is about 2.5% of the total number of parameters of the models. And okay, so this is the code that I use to extract the MIDI file and then translate it into text. And okay, so once we have the dataset, we can start training. At first, I tried using the Hugging Face standard SFT trainer. It's for supervised fine-tuning trainer, and it's very slow and takes too long for me to train. So I do some research, and then I found a library called Unsloth, which they claim that you can get around 2x faster by using this library. And yes, it's faster. I have tried that, but sometimes it just gives me CUDA error out of the blue, and I haven't found the way to fix it yet. So yeah, sometimes it's just train for a few hundred steps and then give me some error. So I have to restart the training again. and I was only able to train for around one epoch. So I'm only able to go through the data set only once, and at the end I get the evaluation loss of about 0.09. Okay, so this is the example of the MIDI that was translated into text and then feed to the model. So it contains instruction and the context, and this is a sample input that I give to the model, about 20 time steps, and this is the response that the model give me. Okay, so now let's go to the output and then listen to what the model generates. Okay, so now that we have the model, we can also adjust some parameter when we generate the text by the models, such as temperatures or the top P parameters or top K. So it's going to, by adjusting this parameter, you can make the model to be more creative, or more like, if sometimes it's going to keep repeating the same phrase over and over again. So we need to somehow make the model more creative, but not too creative. Yeah, so we need to adjust this parameter and then find the setting that work best, which might be different for like different inputs. Okay, so this is the output that it generates from the Bach violin solo that I feed it to the model. Okay, so let's listen to that. Okay, start generating from here. Yeah, you can see that sometimes the phrase seems to repeat, but this one is pretty good. It's the model is able to capture the tempo of the piece, and the note is like, the harmony is okay. And this is kind of a simple piece because it only contains one instrument. Okay, now let's do another one. This is Beethoven Piano Sonata. Okay, so now the model is going to generate after this. Okay, for this one you can see that the harmony is not as good. It's, you can, when you listen, you can clearly see that this is the part that the model generates. So the tempo and the harmony is not as good, because now it has to generate to the left hand and the right hand. Yeah, and now let's try a Haydn string quartet. Okay, now this is the part where the model generates. This one is okay. I think it's kind of okay. The harmony is still there. Okay, and last one. Actually, not the last. The next one is Mozart Piano Trio. Okay, so this is the part where the model generates. Yeah, this one is not that good, but this is the best that I can do after many trials and errors. And this is the last one, I think. This is from a composer that was not even in the training dataset. It's a Vivaldi violin concerto. So for this one, I just made it like give it some composer that, let's say, if this is a piece that was written by Brahms, what would it sound like? And this is what it generates. Okay, so this is parts where it generates. Yeah. Oh, this one is okay. I think it's one of the best one. And from what I can see here, if it's only like one instrument, the output is okay. It's pretty good. But if you have like more than one instrument, then yeah, the model cannot learn about the concept of harmony and things like that. So the output will not be as good. And yeah, that's the end of my Capstone project. Thank you.